Hello guys, so we are back again, and in this session we are going to do some more questions based on Lagrange method of undetermined multiple variables multipliers. Or in the last session we did two questions, and this is probably going to be the last lecture of Maxima and Minima, and after this lecture we are going to move on to successive differentiation. But before going to successive differentiation, revise this chapter properly. And this chapter comes in a combination of partial differentiation and maximum minima. They are a pair only, so it is a group of two chapters, but I have taken it separately and individually so that you can get a clear cut understanding. I didn't get it involved with the partial differentiation, otherwise you will get jumbled up, that you may get confused that these type, how to differentiate between these type of question, so I just separated them for better understanding. Now let's consider the first question in this session, which we are going to solve. The question is as follow. The question says, if 4 by x plus 9 by y plus 16 by z obtained by Lagrange method of values of x comma y comma z, which makes x plus y plus z minimum. So here they have directly told that x plus y plus z is minimum, so it indirectly means that our f of x comma y comma z is x plus y plus z. Now phi x comma y comma z is what? Then you can directly is okay. I think they have given the incomplete question. The complete question is not given. It should be equal to 25. The question is not properly given. It should be equal to 25. So you can make out by implicit function property, or you can understand from here also. Like here we make out that this is phi and this is f of x comma y. So we need to minimize. Okay, get the minimum value of this. Let f of x comma y comma z is what? X plus y plus z. Let phi x comma y comma z is what? 4 by x plus 9 by y plus 16 by z minus 25 equal to 0. Consider the Lagrange function. What we are going to consider? L equals to f of x comma y comma z plus lambda times 5x comma y comma z. So after this, x plus y plus z plus lambda times 4 by x plus 9 by y plus 16 by z minus 25. So here therefore stationary points are, what are the stationary points obtained? Okay, the stationary points are obtained by solving what? Dou L by dou x equals to 0, dou L by dou y equal to 0, and dou L by dou z equal to 0, and dou L by dou lambda equal to 0. So dou L by dou x equals to 0 is nothing but 1 plus lambda times minus 4 by x square. So here what we can see is x square is nothing but 4 lambda, so we can get x equals to 2 lambda. Okay, and if I do it here, get dou L by dou y equal to 0. If I differentiate it, it is nothing but minus 9 by y square, and I differentiated this one into lambda, and this one which will be 1. And if I solve it, you can directly make out that y will move here and it will multiply, and you will get y equals to 3 under root lambda. Similarly, dou L by dou z equal to 0, again 1 plus, and here it will be minus 16 by z square lambda, and here similarly we solve z equals to 4 under root lambda. So we got x, y and z values. Now let's get dou L by dou lambda equal to 0, which is 4 by x plus 9 by y plus 16 by z equals to 25 or minus 25. So if I substitute 4 by 2 under root lambda plus 9 by 3 under root lambda plus 16 by 4 under root lambda, equals to 25. 1 by under root lambda. If I take common, this will cancel out 2, this will cancel out by 3, this will cancel out by 4. We have 2 plus 3 plus 4 equals to 25, which is nothing but this is 9. So we are going to get, okay, we are going to 2 plus 3 plus 4, right? 2 plus 8, this is 5, 9. So what we are going to get here, we are going to get 3, 2, 3, 4, right? We are not doing any mistake over. So if I calculate, what I am going to get, 25, 9 by 25 should be equal to under root lambda. If I move it here, what I can see, this will become 9 square by 25 square, which will be what? So we are getting lambda is equals to 81 by 625. So our next job is to get x, y and z value. So x is nothing but twice under root 81. X is what? Twice under root, sorry, x square is 4 times lambda. If I substitute 4 into 81 by 625, I am going to get x square as 324 upon 625. And if I get x value, it is nothing but plus minus 18 by 25. Similarly, y is equals to 3, y square is equals to 3 lambda, 9 lambda. So we are going to get y is 9 times 81 by 625, and so y value is nothing but 729 upon 625, which is nothing but plus minus 27 by 25. And similarly, z square is nothing but 16 times lambda, and if you know, we are going to write it 16 into 81 times 625, which is nothing but, if I calculate, 1296 upon 625, which is nothing but plus minus 36 upon 25. Okay, so we got these values. So stationary point is, what are the stationary points? Stationary points will be 18 by 25, 27 by 25, 36 by 25, and minus 18 by 25, minus 27 by 25, minus 36 by 25. And here if you observe, our function f of x comma y is x plus y plus z. Therefore f of 18 by 25 comma 27 by 25 comma 36 upon 25 is what? Addition of all these, which will be 18 plus 27 plus 36 is what? 81. 81 upon 25. So, and the other value will be f of 18 by 25, 27 by 25, okay, 36 upon 25. It is nothing but minus 81 by 25. Therefore minimum value is minus 81 by 25. So we are done with this question. Hope you have understand each and every step of this problem, which was very similar, and you just need to know which term you have to consider f of x comma y and phi. So let's move on to the next question. So the next question which we are going to take, where is the next question? Let me get the next question. So we got the next question. The next question is, the temperature T at any point x comma y comma z in the space is k x y z square, where k is the constant. Find the highest temperature on the surface of the sphere x square plus y square plus z square equals to 1. So we can directly make out what is our f of x comma y comma z, which is this one, and we can make out what is our phi x comma y comma z. So let f of x comma y comma z is what? Kx y z square. Let phi x comma y comma z is equals to x square plus y square plus z square minus a square equals to 0. Consider the Lagrange function. If I consider the Lagrange function, L equals to f of x comma y comma z plus lambda times phi x comma y comma z, L equals to k x y z square plus lambda times what is the function, this x square plus y square plus z square minus a square. Okay, now stationary points are obtained by solving dou L by dou x equals to 0, dou L by dou y equal to 0, dou L by dou z equal to 0, and dou L by dou lambda equal to 0. Now dou L by dou x equals to what? We can get, if I differentiate it, I'm going to get kyz square plus 2x lambda equal to 0. Therefore lambda is equals to minus kyz square upon 2x. Why I'm not taking x here? If you observe clearly, when I will differentiate z, the scenario will be, it will be 2z here also, z will be there here also, so z will become 0, which it should not become. Okay, to avoid that we are going to solve it like this. So I got my lambda. Similarly dl by dy, dou L by dou L is kxz square plus 2y, lambda equal to 0, therefore lambda equals to minus kxz square by 2y. This I will call it as 2, this is my 1, this is my 3. Now what is the next? Dou L by dou z equal to 0. So when I do this, it is what? 2kxyz plus 2 lambda z equals to 0. So I am getting lambda value as minus kxy. You can clearly see z gets cancelled out, so it becomes a problem. So you should be aware in these type of problems. So now you got 3 lambda values, and this is what 4. So from 2, 3 and 4 we can compare them. So by comparing, what I can say, minus ky z square by 2x should be equal to minus kxz square by 2y should be equal to minus kxy. So if I simplify them, what I am getting is yz square upon 2x is equals to xz square upon 2y is equals to xy. Therefore z square equals to 2x square, which is our fourth one, and z square equals to 2y square, which is our fifth one. After getting these two, what we can do, we can directly make out that x square is equals to y square. If x square is equals to y square and z is twice equal to x square, so what we can do, we can substitute it in the main equation, okay, which is our dou L by dou z. So dou L by dou lambda will be what? It will be nothing but this equation, x square plus y square plus z square minus 1 should be equal to 0. So if y square is equals to x square and z square equals to 2x square, if I substitute here, I am going to have x square plus 2x square minus 1, which gives me what it brings me. It brings me if I substitute, I have 4 x square minus 1 equal to 0, x equals to plus minus 1 upon 2, right? Plus minus 1 upon 2. And if this is plus minus 1 upon 2, y will also be plus minus 1 upon 2. And one more thing which we can do is z is twice x square, so z will be nothing but 1 upon under root 2 plus minus. Now what we can get, therefore stationary point are plus minus a by 2 plus minus a by 2 plus minus 1 upon a by 2 1 upon, and here 1 upon under root 2 plus minus. There is no a only, okay. So we got this thing. Now we are going to substitute it in this. K is equals to xyz, so 1 upon 2 the whole square plus minus whatever it is, it will be same only, into 1 upon under root z the whole square, which brings me to the end that 1 upon 2 4 into 4 into 1 upon 2 16 32, so k upon 32. Okay, which will be 2 2 4 4 4 16 16 to 32. So we got this answer. Hope you have understand each and every step. Sorry, this is not square only, this is what kxyz. So if I multiply this entire will become 4 and this will be 2, which will bring me to k by 8. So k by 8 is our required answer. So hope you have understand each and every step of this solution. Whenever this type of temperature type question appears, solve it in this way so that you can get complete mark. So we have completed our maxima and minima chapter with this, and we are going to start with successive differentiation in the next lecture, and after that expansion of function. So take care, revise this chapter and partial differentiation, because they are like a family member, they are just a part of each other. See you in the next lecture.